In this video, we'll cover how to use Avogadro's number as a conversion factor to convert between moles and molecules. First though, a quick background on Avogadro's number. The full value of Avogadro's constant is 6.022140076 times 10 to the 23rd per mole. This value is exact as of the 2019 redefinition of the SI base units. The 9th edition of the SI brochure outlines these changes. Avogadro's number defines how many particles are in 1 mole, where a particle, which is also called an elementary entity, can be a molecule, atom, etc. We typically will use Avogadro's number to 4 digits, but keep in mind that the value is still exact, which means it has no uncertainty and will be ignored for significant figures. So how do we use Avogadro's number? Avogadro's number is an equivalency, so we can turn this equivalency into a conversion factor. So the conversion factor will either look like 1 mole of substance over 6.022 times 10 to the 23rd particles of substance, or 6.022 times 10 to the 23rd particles of substance over 1 mole of substance. Only 2 parts of this conversion factor will ever change: the symbol or chemical formula of the specific substance, and particles will become molecules or atoms. The numerical parts of the conversion factor are always the same and never change. Like with other conversion factors, how we set it up depends on the given information in the problem, and we'll let that given information guide us. So let's look at a problem involving bacon. Sodium nitrite and potassium nitrite are used as curing agents in processed meats. Why? Importantly, to prevent microbial growth. Aesthetically, to give processed meat its pink color. Otherwise, it would look kind of an icky gray. The U.S. limits the amount of residual nitrites in cured meats because of the potential health effects resulting from the formation of nitrosamine compounds. In the U.S., residual potassium nitrite in bacon is limited to 148 parts per million. A slice of bacon with this nitrite level contains 2.78 times 10 to the negative 5 moles of potassium nitrite. How many molecules of KNO2 is this? First, let's take a look at what units are presented in the problem. We're given moles of KNO2, and we have to calculate molecules of KNO2. These are the 2 units that are present in Avogadro's number as a conversion factor, so that tells us that this calculation will be 1 step. As always, we'll start with what we're given, which is 2.78 times 10 to the negative 5 moles of KNO2. Remember, we have to write the units and the substance now because they have to cancel exactly. When we set up our conversion factor, we'll write the denominator units first because they need to cancel exactly with the numerator units in our original problem. So because we have moles of KNO2 originally, in order to cancel, we'll need moles of KNO2 in the denominator. That means that the numerator units will be molecules of KNO2. We'll fill in the values. The denominator will be 1 mole, and the numerator will be 6.022 times 10 to the 23. We'll make sure that the units cancel. Moles of KNO2 cancels moles of KNO2. And then to check our sig figs, we have 3 sig figs in our given value. And then remember that both parts of Avogadro's number are exact, so we ignore those for sig figs. And when we do the calculation, 2.78 times 10 to the negative 5 times 6.022 times 10 to the 23, we end up with 1.67 times 10 to the 19. Units are molecules. Substance is KNO2.